voicing what's going on, and it's asking for help. But then sometimes you just kind of have to grin and bear it, grit your teeth, and be like, I can do it, and I'm going to do the best I can on it. And so we'll see how you guys are able to do as we grade. But first of all, today you came together, and we're supposed to bust out these multiple choice. The first one gives us a piecewise function, true? And this is a piecewise function where you have a point, and then you have a function, right? Some of you guys could have actually graphed this if it made it easier for you, and you could have actually said, hey, okay, I have the point 0, 0. Cool, there he is. I have the point 1 minus x, which is a line starting at 1 with a slope of -1 and a slope of another -1. There's a hole here because it doesn't exist there, and then there's a line. Technically only up until 1. This is a tiny baby function. All right, tiny baby function, only up until 1. So you could have actually looked at the picture if that helped. Their question is the function differentiable between 0 and 1? Do you guys see any sharp points between 0 and 1? Any vertical tangent lines between 0 and 1? So therefore, that's true. F of 0 equals f of 1. Are those 2 points the same? That's true. F is continuous on 0 to 1, including the endpoints. False. Good. Letter C is the final answer because don't you guys see how the point does not agree with the limit? That doesn't work at the endpoints. It's continuous between, but it's not continuous from endpoint to endpoint. Check it. Can you connect endpoint to endpoint with a continuous? No, I can't connect endpoint to endpoint. Right? But remember the definition of continuous. The limit is to agree with the point. Here's the at. And here's the approach for the separator 0, right? The at and the approach have to agree. So plugging in 0, just mathematically 1, and plugging in 0 is 0. 1 does not agree with 0. No, 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 no. The derivative is never 0. That's true. The derivative is never 0. Because the derivative of, wait a minute, that doesn't have a derivative. The derivative of is 1. Oh, it's saying that don't even look at 0. Fine. Number 82 says, if the MVT is applied to the function x cubed minus 4x on the interval, then the number c that must exist, we can kind of jump through all the hoops and say, okay, MVT does apply. Forget the continuous, forget the differentiable. I can go straight to, what's the conclusion of MVT? Then there must be an x equals c within a to b such that prime of c equals of, you guys used 2 and 0, right? Look at you guys knowing MVT. That's awesome. Awesome, awesome, awesome. Can't we just plug in? Who's the derivative? Easy cheesy. 3x squared minus 4. Who's this guy? I don't know. Plug in. 8 is 0 minus 0 minus 0 is 0. Well, that's kind of boring. It's a rolls. Hey, hey, hey. Whatever. Okay, so 3x squared minus 4 equals 0. Hence, plus 4 divided by 3. X is equal to plus or minus root 4 over 3. Is there an interval? Yeah, there is. So am I going to ignore the negative one? Yeah, I am. So what's the final answer? Sure looks like D to me. Because it'd be 2 over root 3, 2 over root 3 rationalized. Dun, 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 dun. You went from a C to a D. Usually that's bad, but in here it's good. Okay, it's number 83. Which of the following functions do not satisfy the conditions of MVT? Well, let's review the conditions real quick. F must be continuous on closed interval. Good. Endpoint to endpoint. And differentiable on open interval, in between. Okay, well, let's plug in stuff. Arc cosine, I'm just looking at problems. So this one, x can't equal 3, but is that a problem? No. This one, x has to be greater than negative 1. Logarithms are the ones that have to be greater than. That's okay. Arc cosine takes the ratios, so it has to be between 1 and negative 1, but that's okay. And then this guy, he's an odd-powered root. There's actually no problem at all. Well, that's okay. They're all continuous. Ugh, they're all continuous.
Great.
So what's true? What am I looking at then? And to think about differentiable, I have to look at their... So maybe it would have been a really, 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 really good idea to take the derivatives of every single function. Personifying functions, that's weird. You know you're a math nerd when. F prime of x is equal to 1/5 x to the negative 4/5. Ooh, x can't be 0. Uh-oh. Which of the following do not satisfy the conditions? Hey, I found one. Dun, 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 dun. Wait, maybe there are more? Or maybe I'm wrong? Or maybe... Okay, what if we kept going? So how about letter B? If I take the derivative. Oh, that's gross. Second D first. So that'd be 2 arc cosine of x plus first D second. That's going to be 2x over the square root of 1. Ooh, that's a negative. 1 minus x squared times u prime. Derivative of arc cosine of u, negative 1 over square root of 1 minus u squared times u prime. Oh no, x can't equal plus or minus 1. Oh, that's okay, I don't mind. I'm just looking in between. Oh, so that one does pass. Okay. Letter C, taking the derivative, bottom. Good. Minus top. All over bottom squared. Oh, x still can't equal 3, but that's okay. That's not in the interval, or in the open interval. So that one's still okay. So he's okay, he's okay. I think I'm doing what I'm supposed to be doing. And I think my answer is what I thought it was from the very beginning. Because guess what? This guy's derivative, technically p prime. Sorry, I guess this was an h prime and that was a whatever g prime. P prime is equal to, wouldn't that be 1 over 2 square root of x plus 1 times u prime is 1? Isn't that x can't equal 1? Oh, negative 1? Doesn't matter. I'm looking in between. Final answer was the one I thought it was from the beginning. A. They were all continuous. And these ones weren't differentiable at the endpoints, but that's okay. I don't care about the endpoints. He was not differentiable somewhere totally random elsewhere. That doesn't matter. But he was the one that had a discontinuity of the derivative, aka the original function was not differentiable at 0, which is in between. Ah, he fails. How many of you guys got at least 1 right? CDA. Woo! Keep them up if you have at least 2 right. Keep them up if you got all 3 right. Ooh, all right. We got 2 out of 3. That's not a bad percentage. Any questions that you guys have? What was the hardest one? Probably the last one as far as work. But do you get what I did? Continuous, check domain. Differentiable, check derivatives domain. All right, cool kids. With that, let's go ahead and watch HGTV really quickly as you guys transition to having a colored pen out. Having a colored pen out to grade your homework. As we're watching HGTV, I want you guys to narrow down what questions you have, especially on the odds. What questions you have, especially on the odds. The evens we'll probably look at on Monday. You guys can start grading. Yeah.
Oh, wait, we're grading.
Yeah, we'll grade the evens first. We'll grade the evens first. I'll scroll down just a little bit. Number 22, f of a does not equal f of b. Number 16 was there was a discontinuity. The domain, the function did not exist at 0. That's why they both failed. Number 48 passed. Was continuous on the closed, was differentiable on the open, and so there's the math for finding the derivative, setting it equal to f of b minus f of a all over b minus a, finding the x values, and then seeing are they the c's in between a to b. All right, with that, I think, is that the end of the, very sneaky, end of the evens? Oh, there's more? Ah. 56, you're making an equation of a secant line, which we had help for in our notes, an equation of a tangent line. Graphing them on your graphing calculator, y1, y2, y3, with the polynomial itself, or I should say with the original function itself. How do you put secant in your calculator again? 1 over cosine. Letter C was doing MVT. Doing MVT. This was actually after you did the work. Sorry, letter B, you were finding the secant line. Letter C, you were finding the tangent line, which meant you had to find the derivative. In order to plug it into your calculator, a decimal was probably the easiest way. That's what they did. You could have actually put that in your M spot. That would have been kind of messy, but allowable. And if you graphed it correctly, you should have seen the curve. You should have seen the line between A, f of A, and B, f of B, and you should have seen the tangent line that was exactly parallel. If you did this correctly, you found the C, whose tangent line was the same, whose instantaneous rate was the same as the average, as the secant line. Okay, now are we done with evens? No? Oh yeah, we are. Okay, I was asking you guys to especially look at the odd questions that you have. The evens you just graded, so you might have to go over them a little bit more this weekend to see if you understand them or not. But as far as the odds, kiddos, do we have any questions on the odds? We have a few. Okay, Allie, what do you got?
35.
35. Anything before 35? Okay. What page is homework on? 224. What were the directions for 35, Allie? Is it MVT or rolls, or what were we doing? MVT. But it had some words, huh? This one sounds a lot like number 56 that we were just looking at, kind of, right? Sort of similar with the whole secant line, tangent line, figuring out the C, where they match, etc. So I'm going to go through it fairly quickly, but we have our original function right up here. So our original function, negative x squared plus 5, by the equation of the secant line. Okay, hold on. From our notes, we talked about this one, right, guys? From our notes, we said that an equation of the secant line is going to be y minus, you get to pick a point, just like we do for tangent line, but then for slope, we're not doing the derivative. What do we do for slope instead? Nah, you're thinking normal line perpendicular. Careful. Perpendicular, we do the opposite reciprocal. Secant, we just do a good old-fashioned y2 minus y1 over x2 minus x1, using those points. So to do the secant line, all we had to do was plug in, I don't know, which point do you guys like better? Do you want the first one or second one to plug in? Okay. If we plug in 2, 1, then we're going to go ahead for letter A. I don't know why it keeps on becoming. I apologize. I want red. I'm confused. Okay. I'm done. We're going to do y minus 1 equal y minus y1 over x2 minus y1 minus. So my secant line is going to be y equals, adding the 1 on the other side. 1, 2. Okay, there's my secant line. Letter B says, use the mean value theorem to determine a point C. I'm just going to do this to set that apart, because the whole blue-red thing obviously didn't work. Oh, I need f prime of C, f prime of x, to equal f of b minus f of a all over b minus a. Did you guys find negative 1? Sorry, you guys are quiet. You wouldn't tell me if you didn't. Was negative 1 the slope? F of b minus f of a all over b minus a. Cool. I got some nods. So f prime of x, isn't that just negative 2x? Okay. Which means f Is 1/2 in between -1 to 2? Oh, cool. So I can call him my C. C is 1/2. Okay. Letter C says find the equation of the tangent line through C in the interval through C. Oh. So to go through C, I'm going to have to go ahead and say, wait a minute, that's an x value, right? So I'm going to do y minus f of my C equals f prime of my C times x minus C. I have to go through this point. Tangent line only has one point. It can't be using like 2 points. If you guys think about it, this is a downwards facing parabola that did something like this between the interval and positive. So this was my -1, 4, and this is my 2, 1. I'm trying to find a special C value whose tangent line is parallel to the secant line. So for the tangent line, I can't be using these points. It's not on the line. I need that point, and that point is when x is 1/2. So a is 1/2, f of a is f of 1/2, and then f prime of a is f prime of 1/2. So what do? I plug in stuff, and I say, okay, what's f of 1/2? -1/4, -1/4 plus 5. Is anybody going to 5 is 20/4? -1/4 plus 20/4. F prime of positive 1/2. I could go plugging in, but I already know it's going to be -1 because it matched the secant slope. It's parallel, same slope. So y is equal to 19/4 minus 1 times x minus 1/2. There's my tangent line. And letter D says graph. And if you graph it right, you're going to see the parabola with that line going through it from letter A and that line going through it from letter B and C. And it's going to be nice and perfect and parallel. Is that cool? And that's how you do 56 also. So if you got that one wrong or got stuck, maybe go back and try that this weekend. Grace, what was your question? 61. Let's go peek at 61, but then we got to get to our notes. If you guys have any remaining MVT, we should be able to peek at it on Monday. 60. Oh yeah, this was the one that period 6 asked when I went over a couple questions yesterday. Do you guys remember how we went over that plane problem yesterday? The plane took off and then landed, and we did that rate is equal to change in distance over change in time, miles per hours. Or how we did the pumpkin farmer one, and the pumpkin farmer went a certain distance in a certain amount of time, and so the cops were able to take the distance over the time and say, your average rate was 75 miles per hour. Yeah, right, you were going 50 the whole time, right? Or how we did the one, there was a plane, there was the pumpkin farmer. Didn't we do one more? That's okay. What's going on in number 60? An object is removed from a furnace and placed in an environment with a constant temperature 90 degrees Fahrenheit. If its core temperature was 1500 degrees Fahrenheit, physics tells us it's going to start cooling down, right? If you take something out of the oven, is it going to start cooling down? Take something off the heat, is it going to start cooling down? Yeah. Okay. Even if it's 90 degrees, yeah, 1500 is a whole lot more. So it's going to start cooling down. 5 hours. Hey, there's a time change. 5 hours, it's still blue. 5 hours later, the core temperature is 390. It went down 390. Don't we have to look at those to figure out how much it went down? It was super hot. Now it's still pretty hot, but not as hot. It says, explain why there must exist a time in the interval when the temperature is decreasing at a rate of degrees Fahrenheit per hour. Is that like miles per hour? Mm-hmm. So what do I need? I need my average rate, which is going to be a change in temperature over a change in time. Because isn't this going to be degrees Fahrenheit? And isn't this going to be hours? Oh, let's see what happens. All right, cool kids. How much did the temperature go? It did go down negative. Okay. But we subtracted those two, right? So 390 is the final temperature, minus 1500 is the initial temperature, down 110 degrees. 5 hours. So let's divide. Let's see. 5 into 10 is 2. 5 into 10 is 2. 5 into 10. They were doing. Yeah. How did they make it? They made this so that your average rate would be 222. What on earth could ever possibly tell us that there must be a time then where the actual rate is equal to the average rate? Nobody? Even my hand knew it. MVT. Because what does MVT say? As long as a function, I don't know if it says constant. As long as a function is, so we can say since temperature is continuous and differentiable, it's like motion for all times. You could say at all times, that's a little bit better. And the average rate of the object cooling down. It's an object, right? Yeah, I don't know. Cooling down. Maybe they like were blowing glass or something. That gets super hot, right? Does anybody know how hot it gets? Cooling down is negative. Now we can go ahead and just use their wording because we're like, hey, we've already said that the temperature is continuous and differentiable at all times, hence on the closed and the open. It's like motion. The average rate of cooling down is negative 222. Well, MVT says the average rate must equal the instantaneous for some time. So let's go ahead and say there must exist a time in the 5 hours such that the object's temperature is, just steal the wording, decreasing that rate. I'm going to take away the decreasing and put changing. Does anybody know why? If your proof has any inconsistencies, the AP guys can take off points. If you don't say why MVT applies, if you don't say the part of MVT that you're comparing it to, if you say something incorrect, they have to take off points. It has to be completely consistent, completely your case is what they would say. Literally, like last week when I went to a math conference and there was the head college board lady in charge of all of AP Calculus and the head chief reader who is in charge of grading all AP exams in June in Florida. Florida? Must be cheap. Ugh. But coming back, it needs to be consistent. You need to build your case. I said the rate was negative, and if the rate is negative, I already need decreasing. If I say decreasing at a negative rate, ever used a double negative and someone called you on it and been like, oh, so you are doing that, right? If you use a double negative, what happens? I'm not going nowhere. Oh, so you're going somewhere, right? I'm decreasing at a negative rate, so you're increasing? Careful. If you put a negative, you got to say changing. Or if you put a positive here, then you could be decreasing, but you would have been wrong because you didn't put decreasing up here. You got to be careful. Got to be careful. All right, cool kids. With that, let's get back to our notes. At least that covers some more of your questions, and you've been able to grade the evens. We'll see if you have any other inconsistencies or problems next Monday. But for right now, this whole increasing, decreasing thing, what the heck is going on? It's not a hard idea. It's not a hard idea. Neither is MVT. Not really. Not for easy things like motion or temperature. The pumpkin farmer was going an average of 75 miles per hour. So did he have to go 75 miles per hour? Yeah, he did. He went a whole lot faster, but okay, at least we can clock him at that. That's MVT. Instantaneous rate is going to have to equal average rate at least once, mathematically or practically applied. Example 3.3 says increasing, decreasing. How do we know and what can we do with it? Section 3.3, if you want the short, sweet version. Increasing, decreasing. How do we know without a graph? And how do we use that information? So this is a pre-cal thing. This is a pre-cal thing. Can you guys give me the intervals? Let me show a few things. There's a vertical asymptote at 1. This guy's going to infinity. This guy's going to, well, no, let's stop him. Let's stop him, just for sake of argument. We'll stop him at an endpoint, and this is at 1, 2, 3, 4, no, sorry. 2, 1, 2, 3, that's at negative 3. And then this guy's stopping at 4, 5, 6, 7. And we have 4 right there. We have 6 hitting right there. We have 7 hitting right there. We have 3 hitting, negative 3 hitting right there. Okay, what's an interval where this function is increasing? 4 to, yeah, I didn't draw that connection. Sorry, Nick. 4 to 5. Is it increasing anywhere else?
Oh, yeah, 6.
6 to 7. Ooh, why did I close the 7? It's closed, but this is technically a point and that's a point, right? I didn't include that guy. What's his derivative here? Yeah, so the derivative does not exist. And what's the derivative here? 0. This guy's in between increasing and decreasing, so I don't qualify him as being in either one. This guy's in between increasing, decreasing, so I don't qualify him as either one. But what's the slope of the tangent line at 7? It's increasing at 7. This is an in-between, this is an in-between. This one, if it kept going, it would be included. So the 7 gets included. Sharp point also. But the 4 and the 5 and the 6 do not. All has to do with the derivatives. We'll get to that in a second. Decreasing. Are you all afraid with the negative 3 to open it or close it? Negative 3 to where? To 1. Because from negative 3 to 1, it's decreasing on that branch. I'm going to close it at negative 3. I can also do 1 to 4, right? I had to split it up at 1 because 1, there's no connection here. Can't say what's going on at 1. Nothing is. It's a vertical asymptote. Decreasing again from 1 to 4. Decreasing again from 5 to 6. So why was negative 3 the only one? Oh, that's close. They'd have to give me some sort of clue. But in my head, well, I don't know. It looks like it sloped down. Oh, that could be a 0. It sloped down to you guys though, right? Like barely? I don't know. If it is sloped down, then it should be closed. If it's not sloped down, if it's actually 0, it should be open. And here's why. This gets tricky as to when you put the closed interval. This one was obvious. There was a positive slope there. That was harder. And here's why. Another way to say that a function is increasing or decreasing is based on derivative sign. We talked about yesterday, increasing, decreasing. As x goes up, y goes up. As x goes up, y goes down. That is one way. As x goes up, y goes up. As x goes up, y goes down. That is one way, but you have to know the x's and y's, and the befores and the afters, and making sure there's nothing in between the ones that you're looking at that change it up. So a lot better than the whole before. I haven't missed anything in with the y's going up, y's going down. Especially without a graph, is to look at the derivative's sign. I'm going to put some words in here to try to simplify this just a little bit. So if box prime is positive, then box is increasing. if box prime is negative, then box is decreasing. And if box prime is 0, then box is to not make other math teachers mad. I'm going to say neither. To not make other math teachers mad. I'm going to change it this year to say neither. I had a college professor get mad at one of my kids when they quoted this forever card. This is technically what would need to happen for us to say constant. Constant does not occur at a point. Constant occurs over a time interval. Last year we kind of had to deal with just for a little bit, because some of you realized with some of the wording that I was saying, you're like, oh, so it's constant at that point, and it's constant at that point. And I'm like, no, a function is constant at a point, because a point is an infinitesimally thin, it's kind of like a does not exist time interval. It needs to be constant over, or it needs to be unchanged over an interval in order for it to be constant. I'm trying to think of an example of this. I don't think we have an example. That's okay. This is technically forever number 21. Forever number 21. Days like this, I wish we were on a block schedule. Okay. Forever number 21. So with forever number 21, I don't think we actually need to get to this point first. Let me go here. I know, I'm fully rearranging my notes, just trust me. Identify the open intervals where f is increasing and or decreasing. Here's the struggle, kiddos. If increasing and or decreasing depend on, listen carefully, if increasing and or decreasing depend on a function's derivative, guess what you're going to have to do first? Okay. In this entire section, any problem that has to do with not looking at a graph, but looking at an equation, you're going to have to find the derivative first. Every problem, whether increasing or decreasing, or whether in the section relative mins or relative maxes, the first thing you have to do is find a derivative. I'm going to explain what that means about your homework this weekend and what specifically is due on Monday. It's not the entire thing. Okay, when we're looking at a function, first things first, find a derivative. So the derivative, you have to do quotient rule, right? Bottom all over bottom squared, just like what was a struggle in 3.1 and what was a struggle in 3.2, what would be a struggle in 3.3 for the most part is derivative simplified. So I'm going to end up with x minus x, which cancels out, and -1, I believe. Should probably double check really quickly. X minus 1 minus x. Now, if we're trying to figure out when the derivative is negative and when the derivative is positive, here's a quick hint. What we're going to do after finding the derivative is find our, they're back. Because if you guys realize on that graph we just looked at, what was in between the increasing and decreasing portions? Sharp points or horizontal tangents. Oh my goodness, aren't those the pitchforks of the derivative? So we're going to find the derivative first. We have to separate the derivative in intervals. Those intervals are going to be separated by critical numbers or endpoints. And we're going to go ahead and say, oh, hey, well, -1 x equals 1. We're going to go ahead then and make a sign chart. And for that sign chart, because if you guys just wrote down that forever card, you realize the point of what we're doing is looking at the signs of the first derivative. Our sign chart is going to take two things, the domain and the critical numbers, and put them together in a number line to split up our intervals. Now you could do that two different ways. One way is with a simple number line. The other way is with a table. Both of them give the same exact pieces of information. The number line, we would say, hey, split it up at 1 because that's our critical number. The table would say, hey, let's go ahead and split up our domain at 1 because it's our critical number. Both of them split up domain or the x's in the exact same way. Negative infinity to 1, 1 to infinity. Negative infinity to 1, 1 to infinity. Both of them need to pick a test point, a test value, something in between and something in between, and look at the sign of f prime and the behavior of f. Both of us have us analyze the sign of f prime and the behavior of f. And we could put this in the table if you want. I don't because it's a little bit easier. But we go ahead and take some value, which, I don't know, what's something over there, 0? And we say, okay, what's going on f prime of 0? And then we figure out what's going on f prime of what, 2? If I plug in 0 to the derivative, well, 0 minus 1 squared, that's a positive with a negative. That's going to be a negative derivative. If I plug in 2 to the derivative, that's also going to be a negative derivative. Wait, so the function is decreasing there and the function is decreasing there? What you would do up here is a negative and a decreasing and a decreasing. Either way, we end up with the final analysis of my function f is decreasing. Wait a minute. If it's decreasing the entire time, can't I just say from negative infinity to infinity? No. I have to say is decreasing from negative infinity to 1 and 1 to infinity. Because did anybody realize what at 1? What did I never actually do? Ooh. X could never equal 1. And if I plug in 1, that's going to be 1 over 0. What's going on at 1? A vertical asymptote. So actually, was it a critical number? Technically, no, because f didn't exist there. Should it still have been put in the sign chart? Exactly. It had to have been put into the sign chart. But as we test the behavior, we can't include 1 in the interval, even increasing to decreasing, because the function doesn't exist there. This is what we're doing, guys, in the beginning of section 3.3, increasing and decreasing. We are going to get to where we can go ahead and see increasing to decreasing changes in, which will signify minimums and maximums. But here's the idea. You guys can go ahead and take the picture of this. This is the steps for analyzing for increasing, decreasing box or a picture. However, here's what I need you to hear, and I'm going to put the directions in Google Classroom. For section 3.3, didn't you just see that every single one is going to need, or every single one that asks for, here's a function, analyze, or check where, it's going to need a derivative? Your homework this weekend isn't actually doing this. Your homework this weekend is to go find all the derivatives. Make yourself a little derivative worksheet for section 3.3. Find all the derivatives of the ones that you need and simplify them. Does that make sense? I'll put it in Google Classroom. It's due Monday at 7 a.m. And then Monday we'll figure out, now that you have all these derivatives, how do you use them? But this weekend, find derivatives simplified. Bye. Tuesday, 7 a.m. You guys know what I mean. Yeah. Yeah. Like you're going to start 3.3 just finding derivatives, and you're going to keep going now using them. No. No. Because then you can refer to your worksheet and just steal it and not have to have all the work in the problem. Welcome.